I think today we have an extra special topic that's on everyone's mind. About a year and a half after the big reveal of GPT 3.5, we're going to be talking about generative AI and revenue growth management. So I'm very excited for this one. I think it's something that pops up in every conversation that we have with our prospective clients and also existing clients. So I'm happy that Ingo, you'll help us shed some light on it today and hopefully have some engaging discussions. So while you pull up the presentation, and we still have some more participants dropping in here.
Do you see it? Do you see the presentation?
Yes. Yeah, we can see your not the presenter mode, but the editing mode. So yeah.
And what do you see now? The presenting mode or the editor mode?
The presenter mode. So it's all good.
Say again, but that's the wrong one, right?
No, that's the right one. So
you see the right one. Okay.
Yes. So we can see the right one. And maybe to start off, I wanted to ask everyone who's just dropping in here to post in the chat where they're from, maybe the city and the country, and just to see how international our audience is today. Always like to do that just as a little icebreaker. Thanks, Victor, from Warsaw. I see people from the Netherlands, Colorado, Dubai, Cologne, Düsseldorf, Hatzing, and Lima. Wow, okay. Some quite an international audience here today. Always good to see that this it's pretty small or community is quite international. And it seems like our topic also transcends borders today. So I'm looking forward to learning more about generative AI from you today, Ingo. Let's go to the next slide. Just starting with a quick intro here about our host today. So Ingo Reinhardt will be leading our conversation today. He has over 15 years experience in pricing and revenue management. He also developed the Buynomics method, which we'll touch upon, as it's also a generative AI solution. And then Paul, I've been with Buynomics for almost 4 years. And I've been hosting these webinars for quite some time. On the next slide, Ingo, we can see what Buynomics does. Just as a reminder for all those who don't know us, we do software as a service for revenue growth managers, primarily in the CPG space, but we also have some industries like telecoms. And obviously all of the benefits of AI and software combined in Buynomics. So if you want to learn more, do reach out to us and let us know. But with no further ado, Ingo, I would like to go to the next slide. And when you've discussed it, we also have an audience question. So I'll stay in the line for that one. Okay,
perfect. Yeah, thanks, Paul, for the introduction. And thanks, everyone, for taking the time to join our webinar. I'm sure we have an interesting topic to discuss, and I hope you find what we have to say on the topic interesting. So the topic of today will be generative AI, and particularly in the field of revenue growth management, from the field where I think most of us are from, revenue growth management or pricing. So most of us are professionals in the field. So it's interesting and important how to put these words together and see what comes out of it. And I hope we have something interesting to discuss. As Paul already said, if you have any questions, just put them in the comments. We're happy to discuss. We have some time set aside at the end of this session to discuss your questions. Very happy to do that. We won't claim that we already know everything. I don't think anyone can know everything about the field already. So we're happy to discuss in this session, of course, and also afterwards, if that makes sense. So we already put up the first slide here, and just did a very quick search on Google Trends on the number of searches for the word generative AI or Gen AI, and you see, I think something that every investor likes, or most people who like growth is really a curve that's very exponential. So if you look at it, and it's on the y-axis index to 100, so the maximum, which in the number of searches, which was reached now in March, is indexed to 100, and everything else is discounted here. You see that pretty much a year ago, the topic really gained momentum and had sort of an exponential growth coming from a range of probably below 10 to 100. So that's a multiplier of 20 over a year. So really hot topic, and it makes a lot of sense to think about it. And also, I think what's interesting here in the graph is you see this dip in December. So that means there are fewer searches around Christmas. I take this to be an indication that most people have a professional interest in the topic. And that's why during Christmas break, the interest in generative AI was a bit decreased. But it's interesting to see the importance of the topic. And Paul, you stopped me where we have the survey. I can't hear you. I don't know if it's me or
no. I was muted.
Okay.
If you can pull up the survey now, we wanted to ask people how mature their generative AI capabilities are at the current moment. And there should be popping up a poll. If not, you can also just ask in the comments. But always good to get a sense for the audience today, how they feel about the hype a year and a half later. So I think since you're the host.
Yeah, but GenAI. So the first, yeah, so it should now be up for everyone. But you see the poll?
Yes. So we see actually two polls. That's what happens when Jonathan is on vacation. We're basically
complete
overwhelmed with the technology.
What does it mean?
Yeah, so you have to, you can answer two, but please answer just the one when it says, how do you rate the maturity of your generative AI capabilities? Very low, we haven't tackled this at all. Low, medium, or very high means, you fully implemented and it's very effective. You feel like you're really getting the best and the most out of generative AI. And then on the second one, we can come to that one later. You can click NA for now. But yeah, looking forward to seeing what the audience says today. Audience all over the world.
Yeah, let's give it 5 more seconds and then I'll stop it here.
Also something funny that I want to mention, Ingo, there's John Smith, who's an AI assistant, and he's taking notes of this webinar. So apparently generative AI is already listening to our webinars and transcribing them. Quite interesting.
So you can do the next ones on its own. Do you see the result?
Yes, we do. So it's about a third, almost very low, and another third or 40% almost at low. So it's almost 70% of people, 2/3 saying that they don't even have medium capabilities, and only 1% saying they have very high, fully implemented and effective capabilities. So that's super interesting to me. It's actually a bit surprising. I would have expected that people would rate that a bit higher. Is it surprising to you as well, Ingo, speaking to so many industry experts?
I would say not so much. I think, and we also wouldn't claim that we're at 100%, right? No one can claim that. Even I watched earlier this week a podcast with Sam Altman on the Lex Friedman podcast, and he also claimed that he doesn't know everything. Of course, it's a growing topic, as we also saw in the searches, so no one can claim to already have it all implemented, and because no one really knows what that means, and that's also something we want to discuss today, what we think the road forward is. And what makes sense from our point of view. Let's close it, and I think some already answered the second survey, but we'll put it up at the end of the webinar. All right. So that was already very interesting. And on top of that, we have just here some random papers, things different consultancies, agencies wrote on the topic. So it's not only, as we saw, of general importance and growing, but it's also growing within the field of revenue growth management. So everyone is really thinking about the topic, and that makes it exciting. And I think what we can do today is put some clarity on it and also share our view. So let's do that. And I think the right way to get started is with a definition and an understanding of generative AI, what it means. And I think the proper way to do that is ask a real expert. So we asked ChatGPT what it thinks generative AI is, and I'll just very quickly read through the answer. So generative AI refers to a class of artificial intelligence systems designed to generate new content, data, or information that is similar to, but not directly copied from, existing examples. These systems use algorithms and models to create original outputs by learning patterns and structures from the input data they were trained on. So my point of view, there are three important things here. So they use artificial intelligence systems. Let's leave this open for the moment, what that means. They learn patterns and structures from training data, and they then use it to generate new data. So as this answer already is an example of the output, so this exact definition is probably nowhere in the training data, but it was generated from the training data, and is in that sense based on the existing data, but not identical to some existing data. So probably I would expect that nowhere in the training data this exact sentence is stored. All right. So how do they do that? And we won't go into the technical details here, of course. We're a webinar for RGM professionals, and we'll talk about it in the depth that's relevant, I think, for our field. But how do these systems just work in general? So what they do, and we just had an example of a LLM, a large language model. So what it does is really it predicts the next word always in a sentence, given what words or what meaning was there in the sentence before. So for example, the sentence or the start of the sentence, the price is, can continue with high, low, to, maybe low or high, or just, maybe just right, or just okay, whatever, or in some other way. So what it does is it really looks at the past data at the beginning of the sentence, and then predicts how this sentence continues. And this is how it works in essentially in language models. Similarly, if you think about AIs that produce images like DALL-E, for example, they look at pixels that are already in the picture and then use it to generate the additional pictures, and that's how they generate a picture. And similarly, music works in this way. So you have the sort of the beginning of a piece of music, and then it continues it by adding further notes with certain probability. And this typically, if you, for example, in ChatGPT ask the same question over and over again, you typically get somewhat different answers, but they're all typically somewhat similar. So it always looks at the beginning of a sentence or a picture or a piece of music, and then asks, how can we continue this? And the question is, for us in RGM, what's the proper analogy for us, and how can we maybe apply this technology, or maybe it's not the right way to think about this technology? And I think for us to answer this question, we first need to just maybe take half a step back and look at what we're actually doing in revenue management. And what we're looking at. And essentially what the key challenges that we have is that we have maybe our offer. So we have brands A and B, we have a competitor 1 or competitor C maybe in a shelf. And the things we can do are really maybe change prices. Of course, it always depends on the retailer, but we have maybe some effect on prices or net prices. We have an impact on the promotions we're using. We can change the pack price architecture, the product assortment we have. We can maybe change our offer across different channels. So these are the levers we can pull in revenue management. And the question is, if we use this analogy from the large language models, for example, in our case, the question is not what is the next word or the next node or the next pixel, but for us, the question is what is essentially the next purchase of a shopper. So if I change a price from, say, 2 euros to 3 euros, how will that affect the next purchase of my shoppers, or how will that affect the sales of my products? So I think this is the proper analogy for us. And you already see that's a little bit different than the language example, where the next word in the sentence really depends on the previous words in the sentence. Whereas for us, there is of course, some dependency over time, with seasonality, trends, inflation, these things. But we find much more important are, for example, than seasonality, at least in most cases, most industries, are the questions: what's my product? What's the price of my product? And also, what are the prices of my competitor? What's the assortment, and so on? So it not only depends on the history, so it's not just a time series, but it also depends on the market dynamics, or the market setup in a specific content. So this is the question we need to answer in our case. And when we look at many of the traditional methods, at least we find that many of them are very simplistic. So for example, when we look at something like a price elasticity, which we find is in many cases still pretty much the workhorse for revenue management, we see the question is here, how useful are these tools really as a foundation to build something like a generative AI model or approach for revenue management in the end? And what we find is that these more simplistic traditional methods, like a price elasticity, really oversimplify reality to a very strong degree, and are not like the primary go-to solution for a generative AI model. So for example, when in this case, there are many challenges we typically find with it. So let's say we have this graph, very simple case, we sell a single product, and we, for example, see each dot here is a week, and each week we have a different price, different sales volume, and we can use it, for example, with a simple regression analysis to estimate this price-sales relationship, and we can then use it to compute here the price elasticity. One challenge immediately we see is that here in this case of linear price elasticity, that the value is different in each spot. So for example, here in the middle, it might be the price elasticity -2. And if we increase the price, elasticity goes up. If we decrease the price, elasticity goes down meaning closer to 0. And when we do this all the way, we see that the price elasticity takes each value between 0 and -infinity. So it's really hard to say what's the price elasticity of this product. What you can say is the price elasticity at a certain price point is, for example, -2, but it also changes a lot. So if you increase the price by 10% in this example, price elasticity goes from -2 to -2.7. So price elasticity is something that strongly depends on the current price and changes quite a lot. So that's why it's probably not the best way to build a generative AI model on. Also, I think one of the challenges we already see here, if we compare it, for example, to a language model that we had before, something like if we only say, okay, price sales volume relationship here is linear, then we can describe this curve here, this line, with just two values. In this case, 100 and the slope -25. So there are only two values that completely capture the relationship between sales and price in this example. If we compare that to a language model, something like ChatGPT, I think has 1 trillion parameters. So there's a broad range in the number of parameters that we have. And that also really shows how different something like a price elasticity is, simple price elasticity model versus something like a large language model in these cases. Paul?
Yeah, I have a question here from the audience, Ingo, and I wanted to take it right now because it's related to the slide. So Tiago was saying that this chart should be a curve, and there's different ways of looking at the demand curve. Can you maybe just elucidate that a little bit? There's obviously a simplified chart here, right?
Yeah, I'm not insisting here, and it's a good question. I'm not insisting here on a linear relationship. I think this here serves as an example. I think the most prominent demand curves are the most widely used ones are this linear demand here. And on this, price elasticity changes everywhere. It goes from 0 to minus infinity. Another demand curve that's frequently used is, for example, the exponential demand curve. Or can you see my mouse? Or
yes,
you see it? Okay, perfect.
Yeah.
So which goes more like this. So it has more like a round shape. And in exponential demand, the special feature is that the price elasticity is the same everywhere. So those, I would say, are, at least in microeconomics books, the most prominent ones. And because they're easy to calculate with, but they have one interesting and important feature for us, because they make an implication on, they imply something about the actual people buying the product. So if you have linear demand, that means that the distance between these people here is equidistant. So you have one person essentially, for example, standing every 1 cent or every 2 cents, there's one person, and say, okay, this one might buy the product for 10 euros, up to 10 euros. This one's willing to pay up to 9.98, and so on. If you have an exponential demand curve, that means if you get closer to 0, they get squeezed closer and closer together. So the difference between two of these people is always the same in percentage. So let's say this one here is willing to pay, let's say 1% less than this one. And that means they get closer and closer as we get to 0. And that's something that's essentially, to some extent, impossible in reality, right? Because there are not that many people, particularly if you go to low prices. So that's this, and there are, of course, other demand functions. So, for example, if willingness to pay is distributed normally, like the size of people or weight, then the curve is more like an S, for example. So there are different curves that capture different features and that are differently likely to happen or appear in reality. Oh, this answers the question. But what we're saying is that such a model is very limited because it only works in this case here for this one product. So if you add a second product, it becomes already much more difficult. And in reality, we have probably dozens of products that people can choose from in a category. What I'm saying is only that if you only look at elasticity, that would oversimplify the challenge, and it's really difficult to build a meaningful model on top of that. So with this, I think, or what we think, is essentially this approach. And there are, if we want to work towards a general AI in revenue growth management, we need to think in terms of 4 layers that are important. And only the last one is what I think most people identify as a generative AI model, which is you have some sort of prompt like ChatGPT, where you ask the system a question and it then answers the problem, this question. So for us, there are 4 layers, and we will go through them quickly, one after the other. So the basic layer is essentially getting the data right. The next one is using this to make a good prediction, similar to what we just explained with the linear demand function and the price elasticity, but in a more detailed way. And then using this for optimization, and then building only as a last step on top of that something like a prompt-based approach. And there, I think it's what's most important is something that we'll mention here as well. All right, so I think, and what we will now do is really talk about the specifics of our field, because this is really what matters, and it's really also different for our context. If you compare it, for example, with a language model where you get lots of text from the internet search, or you get from something like Wikipedia. for us, our data landscape is a bit different. In pricing, I think we have, for example, sales data or sellout data, really depending on the industry, that reflect actual sales given in the market. You have, which is always important, of course, to have a good model, product data. So you need to know to some extent what your products are made of, what the brand is, what the size is, what flavor the product is, what its packaging is, and so on. So you need to know these details of the product. You need, if you are interested in optimizing profit, you also need to know your COGS, trade spend, all of these factors. But there's also, for example, survey data in many cases where, particularly if you're thinking about new features, new brands, or you want to change something in the industry that in your products that hasn't appeared in the products in the past, you need to look at, you need to ask people, how do you like this new product? And then the question is, how do we integrate this with existing data? So this is really the challenge, that we have a very broad range of different data sources that are relevant, and we need to integrate them into a single model that we can then use for prediction. And of course, everyone knows who's ever worked with real data, it's always a bit messier than you expect. So there are also many things where, for example, machine learning or other tools can be used to identify outlier, to add missing values. All of these things are important, and these are topics where AI, GenAI, similar models can be used as well. What we find, and it's the approach we're taking, is for our specific problem in RGM, which is, I think, the core or the most difficult problem we have to solve, is really predict the sales outcomes from after, for example, a price change, a promotion change, an offer change. All of these things we need to predict, and the best way we've identified for this is really using something what we call the virtual shoppers. And the idea is really to not model demand in a very simplistic way with just a linear demand function or an exponential demand function, but really model what's going on in the situation. And we do this with something we call virtual shoppers. And the idea is we create a very large number of these virtual shoppers with different behaviors, preferences for different brands. And we do this with the available data sources that differ by industry, of course, using sales data, using survey data, whatever is available and makes sense, and using it to create these virtual shoppers. And once you have them, you can use them to, for example, generate these demand functions. So in this case, in this example, they're not linear, but they have more like this S-curve here. And what it really does is that you have an offer and you have these virtual shoppers, 1 to 3, up to, depending on the company, on the context, a few 100,000 or millions of them. And each one makes a decision between the available products. And this really allows a system like this to be very precise in the prediction of what happens if, for example, you increase the price of product A. Of course, you will lose sales in product A, but some of them go to products 2 or 3, which we can't, of course, show here on the slide, but which you can't see, for example, in a system that measures this dynamically. And this really gives a system like this the detail and the ability to be very precise in predicting what happens after a price change or any other change, not only for the focal product, but also for everything else in the setup. And with this, for example, here's also just shown in a very simplified way, allows a system like this. So we have here 7 products, different nuts, and we have the actual sales, the predicted sales, and you can really see how, for example, changing what products are in promotion, maybe also changing other things, how demand spreads around the whole category in this case. So what we see is that such a model allows the system to be much more precise, and with a much more precise solution allows users then to also identify the profit optimum, revenue optimum, whatever they're looking for, in a much more precise way. So this is really, if you think again at the pyramid we showed in the beginning, these are the different layers that are relevant for revenue growth management before they can really be put to use in a generative AI model. First, getting proper data as a foundation, integrating the different data sources that are available, then using this for a precise prediction. And then in the next step, once you have the precise prediction, you can really look at optimization, identifying the best offer. And here, in this example, I think this is relevant for many companies, because most companies don't just look for profit optimization or revenue optimization, but most companies look for something that's often called profitable growth, which is some combination of profit growth and revenue growth. And what we show here is essentially, say you have a country or a category or a certain channel through which you're selling, and you look at potential price or other offer changes, PPA changes, and each change produces a combination of profit, total profit impact, and total revenue impact. Some changes, of course, always make are worse than the status quo, but with an optimization method like this, you can then identify here this Pareto frontier, which means, for example, all of the dots where you cannot, that are not dominated by another alternative. That means if you're here on the boundary, you cannot further increase profit without losing revenue growth. So this allows a system really to look at, identify what's relevant in the specific case, and then identify the offer changes, price changes, 3, 7, whatever %, plus maybe a change in the promotion plan or a change in anything, in something else that then produces this outcome. And a system like this can then identify the best alternatives that are available in the situation. And then essentially the last step, when all of this is available, is then, I think, what many see as the generative AI approach, that at least from what we're seeing, I wouldn't expect something like a ChatGPT just throw in your data and it will tell you what the right price is. But rather the right way to think about it is that a system like a chat interface that understands the right words for the context can then use an optimization, a prediction model underneath to identify the best solutions. And I think what's specific for our context is, and this is just an example, a conversation you would have with a system like this. So you would interact it essentially in the same way you would interact with a colleague who does the analytics, or a consultant who supports you in identifying your RG or defining your RGM planning. So it would ask it, hey, we're doing our annual RGM planning. Can you help me with options? And the system would say, okay, the maximum net revenue increase we identified 6.7%, but we need to do all changes. So we need to change prices, PPA, promotions. But we know from what you did in the past, you didn't really want to touch promotions or PPA. So if you're only changing prices, you can go up to 4.6% just with price increases. You would ask the system, hey, how can we get 5% increase in the UK market? And it would then provide different options, one maybe only with minimal PPA changes, one with some slight changes in the promotion plan that produce 5%. And then the user can choose, or the team can choose, or management can choose what the best options are. And I think what the right way here to think about is, and what really makes it specific for us, there are 3 things, I'm happy to understand how you think about it, that are required really for a system like that. First is, it really needs to understand the specific terms that are relevant. And these are often company specific. So if you have terms like Like we all have net revenue, net 2, net 3, net 4, and so on. So these can often be very company specific in their meaning, and the system needs to know what a user means with these words, and these are things that it should be trained on. Also, what a system like this should know is have an understanding, maybe from annual reports or from many internal documents, what the overall strategy of a company is, so that it suggests an outcome that is in line with the overall strategy. So when the overall strategy of the company is to favor growth over profit, it should consider this in making a recommendation, an RGM recommendation or pricing recommendation. Also, I think a good way to use these systems is to sort of store institutional knowledge in these systems. So it knows that some companies, maybe they all only use the 99 prices, so 9.99, whereas other companies only use 95 prices. So these are things a system like this should know, so that it only recommends changes that are in line with how the company has priced in the past. Or for example, you have something like the company A never goes above the prices of company B. So it considers this in making a recommendation. So this is, I think, from our point of view, how to think about these systems. And of course, we're all at very different stages of the journey here. But this is how, in our point of view, it should evolve. And the sort of like the prompt interface part is only the very last step in this journey. And this brings us to, I think, one way to describe it. And I tested it with Paul just an hour ago. He very much liked it. So everyone, if you've heard of the halo effect, the halo effect is something known from psychology, where we tend to overestimate the strengths of how certain capabilities correlate with each other. So for example, if we know someone is a good writer, then we overestimate that person's ability in math as well. So we think someone's good in one thing, we assume they're also good in something else. Or if someone's good looking, we expect them to also be intelligent. And we tend to overestimate the correlations between these different attributes. And I think something very similar is going on here with things like ChatGPT. There's also a halo effect in generative AI, in the sense that because ChatGPT can do so many unexpected and fascinating things, summarize my emails or come up with a go-to-market strategy, we tend to think it can also solve all pricing problems. And this is absolutely not the case at the moment. But what it can do, these systems, or what we can make them do, is use tools that we just described. For example, this virtual shopper technology, to make predictions, use some sort of an optimization on top of that to identify the best options, and then use something like a chat interface to steer the system and interact with it. So this is, from our point of view, the way to think about this. And when we bring all of this together, essentially these 4 different levels, from data preparation, validation, integration, prediction of purchases, offer selection, so the optimization, and then the recommendation, we see that for the bottom 2 layers, they should mainly be focused on the precision of the prediction, so really getting reality as well as possible. And the top 2 layers, they need to be trained to become profitable, maybe a bit simplistic, but to identify or recommend the best solutions that are in line with what makes sense for a specific company, that are in line with the strategy, and so on. So this is, from our point of view, the way to think about generative AI and RGM. And just as a last step, again, we asked ChatGPT, what are the future trends in the field? And it produced these 4. I think we already asked the question on how you see them. So ChatGPT expect an increased personalization of products, more real-time decision-making, AI-driven forecasting. I think we looked at these topics, And then the last one is a more intensified cross-functional collaboration, which is also something we're seeing where in many companies at the moment, different departments do more or less the same thing. So you have in RGM a prediction of how prices affect sales in the future, and also in finance when they make P&L forecast, they do their own prediction, and of course with the proper go-to model at the core that all departments can trust. There should be more cross-functional cooperation in the sense that more people work in the same solution and look at the same data. So those are the 4 hypotheses. Paul, what should we do? Should we open the survey again?
Yes, let's open the survey, and then we can just focus on the second half of the questions. Again, we need Jonathan here. The technology is too challenging. Okay, everyone, you can...
Do you see it?
Yes, we can see it. If you can redo the second part of the question, just set your tick marks differently if you can. And then we can look at that as well. But I don't see anything changing here, so maybe it's now frozen. All right.
Do you see it or?
Yes, I saw a focus on real-time decision-making, AI-driven forecasting accuracy. Those seem to be the 2 winners. What do you think about the results there, Ingo?
Yeah, it makes sense. I think what I would have expected, so I expected personalization not to be strong, and I think that's something you hear quite a lot together with real-time decision-making. I think personalization is not just about like knowing what Paul Hanke wants, but also making it possible in the physical world. I think that takes a lot more. I'm also a little bit skeptical, I think, about real-time decision-making. For having access to fast decision-making, but I don't think in most cases that will mean that you change your prices at a retailer many times during the day. What I see is, of course, forecasting, and what I mentioned also, the cross-functional collaboration. Here, the participants are a bit more skeptical, I would say, but I would say 3 and 4 are, from my experience, my expectations, the ones that are most important.
Okay, good. We have a couple of questions, so I'd love to get around to those. So Natalia is asking in the chat, how do you forecast outrange price increases, which are today's realities? So I guess new price points that we haven't seen in the market before. Maybe you can say a few sentences about that.
Just very briefly, happy to follow up on further details, but in general, of course, extrapolation is more difficult than interpolation, but there's sort of a bubble around the status quo where also the extrapolation works well. Of course, if you double or triple prices at some point, it becomes more difficult, but within, let's say, like a bubble that includes reasonable price changes, outside the status quo, we have good experience.
Good stuff. And then Matthias is asking, is the creation of data lakes a precondition to use or implement GenAI to boost RGM?
Sorry, taking the question also what it means. I mean, the way we describe it is, of course, the system that makes a prediction needs to have access to the relevant data. And that can happen in different forms. Happy to discuss specifics afterwards.
All right. And then Raphael is also asking in the Q&A. So please share in the Q&A or chat if you want to get some more questions out. What's the main difference between the GenAI from Buynomics versus regular quote unquote GPT? So I guess large language models versus virtual shoppers. Can you draw some similarities and differences there?
Yeah, so it's always I would say a question of taste. And if you looked at the definition we had in the beginning on what generative AI is, a large language model works in a very different way, right? As describing in a very simplified way, it looks at the past at the beginning of a sentence or a question, and then answers the question, how can you continue this sentence? It always predicts the next word given sort of the beginning of the sentence. And it does this with a transformer. I won't go into the details here, but it trains in a very interesting, amazing, detailed way how a sentence reasonably continues. So it does that with words. In other models that we mentioned in the beginning, you can do the same thing with pictures or with music, but they predict the next note, word, pixel based on what is there already. I think our challenge is a bit different because sales to some extent depend on the time series, like seasonality, trends, and so on, but much more they depend on what's going on in the market at that specific time. So what's the price of the product? Is a product in promotion? What's the size of it? And so on. So our challenge is a bit different. And I think another challenge is for us that the amount of data that's available is much, much lower than what you would have in the language case. So there's much more words in the internet than prices that are available to make the model. That's why like you cannot simply apply the large language model for our pricing case, for RGM case.
Okay, quite interesting, and happy to again jump on a call if you want to learn more or if you want to chat with Ingo about these topics. Victor is asking, I see a field of low code, no code analysis creation, promising on the fly custom data charting. Do you have anything like this in the pipeline? Ingo, do you want to take this one on our product pipeline with data charts and these types of things?
Charts, of course, there are many charts that we are adding for sure. I don't know exactly what you also happy to follow up, but what you mean with low code, no code. But these are features, if you specifically ask about our solution, where we are currently adding a broad range of visualizations to make the outputs more accessible and easier to interact with.
All right. So then we have another one in the Q&A. And by the way, if you need to jump like John over here, do know that there will be a recording sent to you on Monday or Tuesday. So stay tuned for that. Look for it in your inbox so you don't miss any of the Q&A and also not what our next webinar will be about. So the question from Mutalib is, how do we get virtual shoppers to behave like real shoppers? Would be based that in each country and different states within each country, they can be very different. So I guess question is like, on what level would you model shopper behavior regionally, by channel, all of the above? Because they're quite different.
Yeah, that's true. They're different. I wouldn't say there are whatever quite means in the context, but they're typically built on the data that's available in the context, be it a channel, a country, category. So we try to be as specific as possible and that's as available in the situation. Also, typically that's at the level where decisions are made. So you don't make a different decision in I don't know, in every region, or if that's not relevant, there's not necessarily a point to differentiate the analysis on a regional level, but it all typically depends on the granularity of the data that's available.
Mm-hmm. Great, quite fascinating. And yeah, thanks to everyone in the audience that came up with such great questions. Thanks also to John Smith for providing a summary of our presentation here live. It's actually quite good. I was reading it. So you can look at the recording or you can copy paste that text. I think it's quite fascinating. But jokes aside, Ingo, I think we have some more webinars. Oh, and a white paper. That's true. And look at that design. That's quite cool. Ingo, do you want to speak about that new white paper that you actually have?
Yeah, it's very similar, I would say, to this webinar. I think it's a bit more concise, but it really covers the same topics that were covered in this webinar. Put it together, and we'll make it available next week. And I think we'll send a link with the recording.
Awesome. Great. Thanks everyone today for joining us. Yeah, looking forward to seeing you guys at the next webinar. Watch out for that recording, read that white paper, come back to us with any questions, and get in touch if you want to learn more about Buynomics, our virtual shopper AI, and how we leverage it to help companies get better at RGM and hopefully transform their enterprise into the RGM enterprise of the future. So thanks everyone. Have a great weekend and see you soon.
Thanks. Have a good week.